Hello, Julie. I looked at your problem, or our problem, and I agree with you. I get the same B that you got with the 8 pi in there. He doesn't have the, yeah, it's just a 4 in there instead of an 8. And if you check his answer against x, he agrees with us as far as x is concerned. And if you check his answer against x, remember it has to satisfy that property that x of big T equals x of 0 times b. His doesn't work, so there's clearly something wrong with his answer. However, the rest of the answer is okay. And, as far as D is concerned and P of T, etc. Let me show you how I came up with similar answers. It's a little convoluted. The idea is once you got B, you have to extract D from B. That's sort of the mysterious part. Like he came up with this D here. Now, how did he come up with that? That was a troubling point. Here's how you can do it, maybe other ways. This is true in general. If you take a matrix of this form and you apply the exponential function to that matrix, it will always come out to be this thing here. And proving that is just a matter of looking at the terms of the exponential function. Well, let's just grant that. So using that fact, our problem, we know what x of TD has to be. We know that B has to be x of big T times D. And going back to our, let me clear some of these things. Going back to this B, we can rewrite it like this, where the T is in place of the 2 pi. And looking at that and our test case up here, we see that TD should be of this form, because that's what exp does to things. That if you have a T and a T in the diagonals, it's going to be E of T and E of T over on this side, which is what we have here. And then if you have Z down here, you're going to end up with Z times E of T in this section. So this fits then. 4T becomes 4T times E of T. So that tells us then that D has to be this thing back here. Kind of crazy way of getting it, but it works. And once you have D, you can then use this formula to get Y of T. He went over this in class, and you just, once you see how it works, you'll see why it makes sense. And in this case, if you work it out, you get this thing here. And how do you know that that's x of TD? Well, you go back to this pattern, and you can see what exp of little t times d is going to have to be. It's going to look just like this thing over here. Again, let me clear some of these things. It's going to look just like this thing over here, except it's going to have a little t instead of the big T. It's the same function being applied to two different values. And here's a little check over here, so it does work. And then finally, to calculate P of T, you know that, hang on, let's see how I did that. You know that this has to be true up here. What do you know has to be true? Well, here's what, I don't have it up here. Let me write it down. Here's what you know has to be true. X of T has to be equal to P of T times Y of T, because that's the decomposition of X. Okay, that didn't work out. That's 0.01, so there's something wrong there. First, let me get rid of that. We don't need that. What's wrong is I put the wrong thing in here. Okay, now the 1 says that's true. We know this has to be true, so that'll tell us how to get P of T. We just solve this thing. We know X of T, we know Y of T, so then P of T has to be X of T, and we multiply on the right by Y inverse of T, and so that's how we get this thing down here. And you work it out. Here incidentally is what y inverse of t looks like. So you just work that out, and lo and behold, it does come out to be a periodic function. And I think that's it. So let me just say one more time. This is sort of the missing link for me, this fact here. Once you know that that's the case, you can see how to extract D from B. That's this process down here. Again, let me get rid of some of these things. Okay, so I'm looking at this here. Once you agree to that, and we're just accepting that, then you say, well, this has to be true. D has to be this matrix here to give you the B that you want. Remember, B has to be exp of big T times D. And again, down here, how do you get y of t? Well, we know it's exp. We know it's this. It's exp of little t times d. And we go up and plug that back into this formula, and that comes out to be this thing here. So I think that's it.